Testing, 1, 2, 3, 4. And we're live! Welcome to another edition of RockSim Live. I am Tim Van Milligan. I'm the host today. I wasn't here last week, but I am here this week. I wasn't supposed to be here this week. I was supposed to be in Texas for my daughter's diving competition, but because of the major winter storm going through the country, that got canceled. So we decided to stay home. We didn't want to be on slick, icy roads in Dallas, Texas. So here we are. So we'll be gone, I think, in a couple of weeks to Texas because they just rescheduled it down there. Yeah, so here we are again. This is RockSim Live. This is where we talk about RockSim, RockSim Pro, and the Launch Visualizer. And I am looking for questions. So I have the chat going on right now, so be sure to put your questions in the chat. Also, if you'd like me to say hello to you, put your name, or you don't have to put your name, you just say where you're watching from. We typically have 1 or 2 people from other countries, which is really cool. So we are an international audience. So far, I've got David here, and he is from Michigan, but today he's in Florida at the beach. And we have David HP9Y, and he says, David in Texas. I have an account online for a RockSim Visualizer, but not able to load new files into the visualizer. I sent a message to Apogee without a response. Okay, but that's a good question. Yeah, I can give you a response today. It's not going to be a good response, but I can give you a response. David in Michigan, but he's in Florida right now. He says he's at Jacksonville Beach, and he says it's 67 degrees there with a breeze. So it's warm enough to go without a jacket, but not quite warm enough to go into the water. That's kind of what I expected this time of year, unless you're like really far south. And he had a question, and we're going to get to that. And Richard Ray dash S2S, he says, hello from inversion-covered Boise. Boy, I wonder what the weather is in Boise today. Let's see if we can find out. Let me open up a new window here. Let me show you my screen after I get off of this page. Okay, computer screen. So hopefully this is working. Okay, so here is, this is windy.com. And this shows temperatures. So Boise is right here. It's kind of like the bluish green. So they're in the 10 to 20 degree. Oh, it says 32 degrees right now. Yeah, that's warmer than we are. We're at 17 in Denver. And Jacksonville, let's see. Palm Coast, Jacksonville shows 71. Palm Coast is 68. I used to be in Daytona Beach when I went to college. That's 66. Let's see what it is in Miami. 75 in Miami, 77 in Homestead. I love this website, windy.com. This is great for RockSim because it can show you your wind speeds. So right now, am I showing? We're showing wind. Oh, this is in knots. So right now, it's like, right now we're blowing in this like 10 to 20 band for Colorado Springs. It's kind of breezy. We got some light snow going on right now. Yeah, even 64 in Los Angeles. So it's not so warm there either. Let's see what if I would have gone to Dallas. It'd be 46 degrees in Dallas, so it's still above freezing there. But it was supposed to get icy tonight. So thank you, Richard Ray, and we have Explorer 828, that which is David in Michigan. He says 1 degree actual in Michigan, minus 17 with the wind chill. Yeah, it shows -2 in Lansing, -1 in West Branch. I've got family along the lakefront here. Yeah, it looks like it's, oh, it's pretty cold there. Pretty cold. -6 in Chicago. Today's not a good day to be in Chicago. -13 in St. Paul, Minnesota. Yeah, today is a good day to be indoors watching RockSim Live. So thank you for coming. If you are new to RockSim, it's at apogeerockets.com. And you'll see our banner here for RockSim 11. And then there's also our newsletter sign up. And we'd like you to sign up if you already haven't signed up. Every week we put out either a video or a newsletter. This week was a video. Next week will be a newsletter, a PDF that you can print out. It'll have instructions for building a carbon fiber airframe. And it was written by the students at the University of Nebraska in Lincoln. So that is what you have to look forward on Tuesday, but only if you're a subscriber. Here is RockSim Pro, and I think I passed the Launch Visualizer. And that was our first question about the Launch Visualizer. So if you click on this, and it will take you to rocksim.com, which is the Launch Visualizer. We have some problems with, let's see if I remember my password. I don't remember my password. I can't log in. I can only be on the free version. But his question was he can't load a new design. And we know about this problem. And right now, we're between programmers. We're trying to hire a new programmer for RockSim and the Launch Visualizer. Because our old one quit, unfortunately. And it's been a couple of months since we've had anybody working on it. And so we don't know how this bug popped up. It shouldn't have popped up because we haven't made any changes at all to the Launch Visualizer. So you can't load a new design. Let's see if I can load an old one. I can load that old one. Let's see if I can run a simulation. So I don't know my password. I thought it was on this computer. Let me try. It's typing something, and I'm not doing the typing. My hands are up here, and it's typing. What the heck? Let's see if it works. Okay, well, I am logged in. Let's see. Choose a design. Airmail, select. But I don't think you can upload a design. Let's try to run a simulation. So when you're logged in, you can change where you're located on the map. And so this launch site is in Pueblo, Colorado. It's on the outskirts. The main city is over here, Pueblo. And if you're unfamiliar where Pueblo is, it's kind of like south of Colorado Springs and south of Denver. Kind of like, here's the border of the state. So it's in the southern east side, more towards the central. And all these thumbtacks are launch sites or clubs around the country. The red ones are the NAR, the blue ones are Tripoli, and then the green ones are somebody's personal launch site. Or that one there must be on the other side of the globe. Yeah, it's on the other side of the globe. So if you are launching in, here's a launch, Michigan, Michiana, rocketry. And if I zoom in, there's their launch site right there, that thumbtack. And, well, that's a tree. I don't want to launch from a tree. So I assume they're launching somewhere out here in the field. So I'll put my launch pad there, confirm the launch site. And then I'll go to the starting state. So we're going to launch straight up. Launch conditions. I'm not going to change any of that. Let's see if I can load a motor, choose an engine. Yeah, so here's where the bug is. I can't pick a motor. Yeah, so right now the launch visualizer is busted. Pretty much the only thing that you can use it for is getting the launch coordinates of launch sites. I still use it for that myself. So what we're doing is, if you have an account on the launch visualizer and you can't use your account, so what we're doing is we're temporarily moving everybody over to RockSim Pro, which does the same thing, except for this part here of finding a launch site. So you can as long as you have the coordinates, you can put the coordinates into RockSim Pro. But getting the coordinates is a little bit harder. Using the launch visualizer is so much easier. So if you don't have a RockSim Pro account, email us and we'll give you an unlock key for RockSim Pro, because you're paying money, and so you might as well use something. So, and RockSim Pro is actually, it can do a lot more than the launch visualizer, other than seeing this map and selecting launch pad locations. So do that and we'll take care of you. You know, you can trust us here at Apogee. I hope you can, to take care of you. And I heard from the company that has the programmers and they have somebody lined up. We just need to finalize the contract and get it working, and then basically that programmer, it's going to take them probably a couple months just to dive into the code and find out where things are so they can start fixing things. So sorry, again, I'm sorry for that problem, and we'll take care of you as quickly as we can. But RockSim Pro is working fine. We were able to fix one of that bug. So that was David H. P9Y in Texas. So we had another question from David H., who's in Florida. He says, can you simulate different parachute shapes in RockSim 11, trying to aim 40-inch recon recover on a 3-inch Mad Cow DX3 fiberglass that will weigh in at 4 to 6 pounds? Okay, so Mad Cow. So I'm going to go to Mad Cow Rocketry. Let's see if I can find a DX3 fiberglass RockSim file. Search DX3. 245 results for DX3. Oh, come on. Let's see. Certification kits. Let's go to kits. Let's try this way. 3-inch diameter fiberglass. So now I'm looking for a DX3. And if we can't find a DX3, we'll just use something else because the process will be the same. Still looking. $400. Wow, that's a kit. It must have been carbon fiber, fiberglass. Okay, I can't find one, so we'll just choose this rocket. And he usually has RockSim files. Okay, come on, mad cow. Oh, dual, here we go. Well, this is 2.6, so maybe this will add to cart. One review. Download the assembly, download altimeter. Okay, so we'll go to an Apogee kit. So let's go to, let me choose a kit. So I'll go to all rockets by manufacturer, and I want to go down to Wildman. So Journey 75. So this will be a 3-inch kit. So what you'll do is you go down here, click to RockSim file, and it'll take you down to the bottom of the page. Then you can download it, and it threw it in my downloads folder. So if I open my downloads folder, where's my downloads? Downloads, Journey 75. Okay, so I'm going to open up RockSim Pro. This will work in RockSim Pro, identical. So, so here's my Journey, the Journey 75 in the downloads folder, and just take it and drag it onto RockSim. And then it's going to ask me, do I want to save this one? I'm going to say no. Okay, so here is that rocket. So imagine this is your Super DX3. You have to have a RockSim file. So if we look at it in 2D, we see that this item right here with the P, which is behind our center of gravity, is our parachute. So his question is, how do you simulate different shaped parachutes? So let's double click on that, and it highlights it here, and it'll double click there. So now we're editing the parachute. So here are the different shapes we can use. So round, a triangle, a square, a hexagon, an octagon, up to 24 sides. So this is how you simulate it. But the image that you see will always be a round, but it will actually simulate the area of these. So right now I'm on an 8-side parachute, and I think he said 4 to 6 pounds, 40-inch. Okay, so 40-inch parachute. So I just changed the outer diameter here, hit the tab key. You can see my parachute enlarged a little bit. So my calculated descent mass, right now it doesn't have a rocket motor in it. So my calculated descent mass without the motor is 1,455 grams, and we'll change that to pounds. So this is 3.2 pounds. Let's add a rocket motor and see if it bumps it up. So I'm going to click OK right here. You don't see the OK button, so there's the OK button. Okay, so click OK. Now to load a rocket. So in order to run parachute simulations, you need the rocket motor because we need the mass of the motor. So we're going to add that. So I'm going to click over here. We're going to choose an engine. And typically, you want to choose as big of an engine that you're going to fly. So on this one, we'll say we'll fly up to an H motor. And I'll just grab an H. And I just randomly selected this one. So my delay, I usually pick the longest delay and then hit OK. And then we're going to click OK here. You'll see that over here on the screen it loaded the motor, And if we go back to the parachute, now we have a descent mass of 1605. Before we were in the 1400s. So now we're at 3.5 pounds. So you're going to adjust the weight of your design, make sure everything is okay to get the same mass. And then it's just a matter of running simulations. But on this screen right here, it's already pre-calculating the descent rate. So based on this descent mass and this size parachute and this shape parachute, my descent rate is 15.32 miles per hour. That's fast. And so right here we have 3 buttons: low, medium, and high. These are preset descent rates. And if you click on them, watch this number change. So a medium descent rate, which is kind of like an average descent rate, we click on that, you'll see that a medium descent rate is 8.9 miles per hour. And so previously we were at 15. So if I went to a high descent rate of 10 miles an hour, we're pretty high, and that's using a 60-inch parachute. So when I click these buttons, what changes is the outer diameter. So if I go to a low descent rate, now we're at 7.89. Okay, so something didn't change. My outer diameter should have changed. It didn't change. It changed before because it was set at 40. Let's try setting it back at 40 and hit tab and then hit low. See, then it's set to 60. Let's change that again to 40. Hit tab and then hit high. Wow, it's just weird that it's changing high and low is 60 inches, and that shouldn't be. Let's change this to 75 inches. So if I make it 75 inches, then I get to this like low rate. And if I go down to 40 inches, then I'm getting that 15. And if I want to get to somewhere around 10, it's going to be between 75 and 40. Let's guess 55 inches, hit tab. So 55 inches is still not big enough. So let's try 60 inches. There we go, 10.2. So that's what I use for picking parachutes, is this screen right here. I don't even run a simulation. It's like all we care about is the weight of the rocket, the size of the parachute, and that's it. So picking parachutes is not that hard. Just use this screen, and this is identical in RockSim and in RockSim Pro. Save my changes? No. Okay. Okay. Low Budget Bob says it's a nice 68 degrees here. I think he's in Arizona. Dr. Disco in Austin, Texas says, recently got a kit that does not have a RockSim file. I dove into RockSim Pro and created a model from the parts. Only thing I struggled with was the fins. Okay. He didn't say he had a question. Okay, he says that the rocket is a Vaughn Brothers Extreme 24. Well, I'm not going to search for a RockSim file because if you didn't find one, I'm not going to find one. So what we'll do is we'll take this one right here. We'll delete the fins. So you highlight them here, highlight them up here, and hit delete. It's going to ask, do you really want to delete? And I'm going to say yes. Okay, so so Dr. Disco, what we're going to do is add a fin. So to add a fin, the first thing you got to do is select the component it's going to be attached to. So I'm not going to attach it to a parachute. I'm not going to attach it to the nose cone, although you can. typically you're going to, fins are attached to outside tubes. So this is an outside tube. So then the fin buttons all line up. So there's 4 different fins. There's the regular fins. So regular means trapezoid or elliptical. Those are your 2 options. Custom fins are flat fins, but they can have any shape, including trapezoid and elliptical. But it could be anything. It could be, you know, an octagon or a bat wing or any shape that you can think of that you can, you know, print on a piece of paper and cut out. That is custom fins. That's the most useful one. Ringtails are a ring that goes around the outside of the tube, and that ring acts like a fin. And then tube fins, instead of going all the way around, it's a tube strapped onto the outside of the fin, and then you do multiple tubes, and you can make a stable rocket like that as well. So you said your fin on the Vaughan Brothers Extreme 24 is straightforward. Let me see if I can find a picture of it. Vaughan Brothers Extreme 24 rocket image. There's a Vaughan Brothers Extreme 38. All right, let's say if it's this one right here. Okay, so let's assume it looks something like this. There's actually, I don't know, I can't zoom in on this. But so this is not a trapezoid, so this is a triangle. So we can't use the regular fins for that. We will have to use custom fins. So select the body tube, come over here to custom fins, click on that. And the first thing it does is it tries to find a fin from the database. Typically, you don't know what these look like, so it's anybody's guess. So I'm going to cancel out of the database. And then it takes you to this screen right here. This is the editor screen. Let me make this as big as we can so that... and when it creates the editor screen, it throws an imaginary fin out there. And what it tries to do is to make sure that the rocket is stable. So our center of gravity is right here, and the center of pressure is back here. So this is a stable rocket. And we have a motor in there, so we definitely know it's stable. So now we need to change this shape into a triangle. So what we're going to do is we're not going to, the database we already looked at, you know, that was this. So we don't want this screen. So we're going to go to plan points, this tab right here. And this shows you here on the left side the current shape of the fin. Down here you can also see it, but this is where we're going to edit the shape. And I can grab those corners and you'll see that the shape of the rocket moves. And this is why you can change the shape to anything you want. You can add points just by clicking, and it just adds the points. And then you can also remove points. I think it's this button right here is the remove points. So I can remove that one, remove that one, remove that one, remove that one, and look, now we have a triangle. So now it's just a matter of making this triangle look like this triangle, or making this one look like that one. So why does it do that? Always does that. I don't want to do that. Okay, so basically we need a longer base on our triangle. So currently, if you come over here, okay, it's plan points. I want to just see where the location of this fin is located. So the location is 26.8 inches from the front of the owning part. So The tube, remember, is our owning part. So from the front of the tube to where the fin starts is 26.8 inches. So now we want to make this longer. So if I make it longer, my fin is going to hang over the edge of the tube. So my first thing I'm going to do is I'm going to change the location from the reference point from the front to the base. And when we change that, so now it's located 0 inches from the base of the owning part. So now it's looking at this point instead of that point. So if I make the fin longer, the base is going to stay the same place, and it's just going to extend it up the tube. So I'm going to go back to the plan points, and then I'm going to grab this point right here. I want to change you. It won't let me change you. You can always come up here to this one, double click on it, and let's call it 10 inches. And then hit the tab key, and it jumped out to 10 inches. So now it's really long. And why did the base change? We still want it here. Okay, so now it jumped back. It just kind of had to recalculate. Okay, so now we want to take this point up here. I'm still trying to delete that. That's what was going on. I had the delete button still checked. So if I move this point, now I can move it. So now I'm going to grab this point here, and I'll move it here. So now we're getting pretty close. I think it needs to be a little taller. All right. And that's it. We've just created the fin. If I click OK, it takes us back here, and you can see our fin is now designed. So again, that was, you go to the fin set, go to the plan points, and you can add points. You can drag points around. And you can create any shape that you want. I like that fin shape. Except I don't like that point right there. And you can also, these are the coordinates of the points. So if I click on that point right there in the chart, it highlights it so you know where that point is. And then you can always tweak these dimensions. So if you want to make it exactly 4.5 inches, type in the number and then hit the tab key. So if I make this one 2.6 and hit the tab key, it'll jump down. And you can do this to all of them just to make sure, you know, all your numbers are just nice round numbers if you want. There's an undo button here. You'll undo the last thing that you did. There's preferences. These preferences are for colors and things like that. So there's the grid size. Here's the y-axis. Here's our colors. So our background color is white. I can change that to blue. Click OK. And now we have a blue background. I don't like that, so you can undo. Well, I guess you got to go to preferences. Go to fonts. Background color, white. So you can change, you know, the point colors, the line colors, the grid color, the label colors, all that good stuff. So that's your custom fin. So you can't make that shape using the simple fins, the regular fins. So this one right here, again, it always looks in the database. It added the blue fin. Let me change the location so you can see. Here I can't change, you know, I got a root cord length, which is what attaches to the tube. The tip cord length is way out here. That's this length. The semi-span is how far the tip is away from the root. And then you have your sweep length and sweep angle. These are actually both the same. They control the same thing, and they just control, you know, when you sweep the fin. But I'm limited, you know, when I'm using the regular fin set, it's got to be 4 points. and these have to be parallel to the tube. You can also, well, you can make an elliptical. And then you can change the root cord length. You can't sweep these like we could with the trapezoid. If you want them swept, then you do have to use the custom fin editor and put them in as points. So anyway, I hope that answers your questions. And Dr. Disco says, and that is exactly what he did after a bit of trial and error. Well, that's good. What happened to my RockSim? Did I accidentally quit? No rocket design file, open recent. Okay, so here are elliptical fins, and it shows these as regular fins. So the icon here is different for the regular fins versus custom fins. So a custom fin will kind of have a rounded edge on it. Okay. We still got plenty of time, and I don't have any more questions. So yep, come on, give me some questions. If you're brand new to RockSim, let me see. I don't think I did my my intro on where to find information. So if you're brand new to RockSim and you're looking for information, come here to How To and Guides. Come down here to Software. Click on Software, and then over here you'll see there's RockSim How To info. So if you click on the video tutorials, there'll be a whole bunch of videos. So like video number 9 is how to create a new design. So if you're like, I would recommend going through at least these first 10 or 12 in order, just because it kind of sets you up like how to move your way around the screen and change things. But eventually you're going to want to design a rocket, and then you get to video number 9. So the very first one is, okay, let's just open RockSim and just run a simulation as fast as we can. It's kind of like you're going to have a rocket, and you're going to come up here to this button right here. This is our Prepare for Launch button. And this shows you we need to make engine selections. That's our first thing. And we're just going to move along those tabs. And this is a 2-stage rocket, so I can see my upper stage, and that's this icon right here. This one down here is the booster stage, and you can see it's lower than the upper stage. So then to pick a motor, you can either highlight the row and hit Choose Engine, or you can just double click on the row. There was I guess it did crash. Finally getting the report. So now we can select a rocket motor. This was the upper stage, so I'll do an A3-6 in the upper stage. Click OK. So that's my upper stage. In my lower stage, I'll select that and then hit Choose Engine. This time I want an A10-0. Click OK. So now we have our engine selected. Our next tab over is the flight events. This controls the recovery system. So in this particular rocket, it's telling me all I have is a streamer, and I need to select a criteria, and we're going to say deploy the streamer at maximum ejection delay. So our ejection delay for the upper stage where the streamer is 6 seconds. So at 6 seconds after motor burnout, it will deploy a streamer. Our starting state is sitting on the launch pad, And so you look at here, we got a launch guide length of 96 inches, and that's kind of long. That's for a high power. So we'll make it 36 inches for a small rocket like this one. Hit the tab key and it jumps down to the next one. This is our launch guide angle from vertical, and right now we're launching straight up. There's this slider bar or wheel over here that controls the launch angle. I would keep it on the positive side and not on the negative side, because it can cause confusion, because the next one down is the azimuth angle. So the azimuth is like a compass direction. So when it's pointed straight up, that's north, and when it points straight down is south, and this would be to the east, and this is to the west. And you can see the numbers change as I move the wheel around. So to the east is 90 degrees, and you can type in a value here if you want. So right now I am launching at an angle of 2 degrees towards the east. But if I make it a negative number, now instead of going east, I'm going west. And so that can be confusing. So just keep your launch guide angle as a positive number instead of a negative number. You know, and you want to keep it, you know, under 30 degrees from vertical. So here's 15 degrees from vertical. And our launch guide type, you can ignore this right here. This is kind of some of the advanced stuff. You know, we can have it drifting with the wind or fixed to the earth. So drifting with the wind is, imagine you're on a hot air balloon and your hot air balloon is moving with the wind. And what that does is it gives the rocket some horizontal velocity. So if you were in an airplane and, you know, if you angled your rockets straight down at 90 degrees, launch guide from vertical. So now we have kind of like, you know, missiles on an airplane. And now the airplane is drifting with the wind. And you can give it a starting velocity. You know, maybe we're doing, you know, like 300 miles an hour. And you can also give it a roll rate. Typically, your rockets don't start with a roll rate, but some of them do. So this is, I get 90 degrees from vertical. And the problem with this is, you know, the next simulation controls, I would just ignore this. This is like just setting up the math behind it. So ignore that one. Go to like the launch conditions. So this is the location on the Earth. And this is where RockSim, the Launch Visualizer, would really help. So you can actually see where you're launching from. Because right now I'm just using numbers, my latitude and the longitude. I have no idea where these numbers are. The latitude is a positive number, so we're in the northern hemisphere, 42 degrees. So Colorado is like around 38-ish, somewhere, 38, 39. So this is north of Colorado somewhere. And then 90 degrees from Greenwich in England somewhere. So I don't know where this is. Maybe on the East Coast somewhere. Quarter way around the world. We won't know until we actually run the simulation to see where it is. This shows us our wind, and again, this is a little bit advanced. So I think when you start, they're both set to 0, which means no wind, which is fine. And then we run you can do a launch or a flight profile. So if I did a flight profile, and this is going to go really quick. Yeah, it went really quick, all right. Right here, it shows that this rocket crashed. And the reason it crashed, and it's going to load the map. Let's see. I gotta see if I'm seeing the whole screen here. Okay, so let me zoom out. And I don't know where this launch field is, but it's a nice field. It's along a road. But my rocket is on the ground at a 90-degree angle. So when it launches, it's not taking off. It's going sideways. So basically, this rocket just crashes really fast. So to change that, so imagine you're in an airplane. I'm just playing around right now because I don't have any questions. Oh, Low Budget Bob says, you missed a question. What dictates the CP of a rocket? Okay. I'll come back to that one in just a second because we can talk about that one after I got you hanging on this simulation of launching from an airplane. So to change this simulation from launching on the ground to launching in the sky, we have to change our starting location. So right now, our altitude that the rocket starts at is 227 feet. This is above sea level. And the landing zone altitude is 227 feet above sea level. So what we have to do is you have to change this number right here. So let's make it 5,000 feet above sea level. And the landing zone altitude is still 227 feet. So now when we do launch or flight profile, we should get a much long altitude at deployment was 4,200 feet. We're still aimed down. But let me go to this one right here is the trajectory view. And the reason I chose that is because it's a little easier to find where the rocket is. Okay, so I don't know where my rocket is. It's somewhere. But if I click this button right here, it will find the rocket. And so it found the rocket right here, this red dot. And that red dot is 5,000 feet above sea level. And if you look here, we're actually aimed straight flat. So where's our rocket? There's our rocket right here in the sky. And when we launch it, let me zoom out a little bit so we don't lose our rocket, just in case it goes far. And so the rocket is moving. You can see it's starting to go down. Gravity is affecting it. And then the streamer came out, and there's two lines right here. This is our booster stage tumbling, and this green one right here is the rocket coming down. And we're at 17 seconds, and this is going to take like almost 3 minutes, 2.5. So the booster landed right here, and the rocket is still drifting way out there. And so that's how you launch rockets off of an airplane. And so I think when we set it up, we gave it a starting speed, didn't we? Yeah, 300 miles an hour. Let's change it to 0 miles per hour and hit flight profile. Let's see how the trajectory changed by saying, hey, we're not moving. I'm going to go to this one and find my rocket. The rocket must be, find the rocket. The rocket must be like right there. I don't know, you can't see even that green dot where my cursor is. I launch it. So now it's 134 seconds instead of 137. You can see the rocket took off really fast. Oops. And it's starting to drift downwards. And so the trajectory, it kind of looks the same. But we can compare trajectories. So what we'll do is select both of these. You can do in RockSim Pro. This is kind of a neat feature. You select both of these, and then you hit the flight profile button. And it says the selected simulations have different launch sites. These are identical. Show the launches with different locations. Okay, so it's running the simulations. has to run it twice. Okay, and now it's going to show us go here to this view, and this dot here is the rocket. So if we launch it, okay, it started out the same. Okay, so there's two green lines. And now it's a matter of figuring out which green line is which of the simulations. But it kind of looks like fireworks, right? So this one should be a yellow line because that's a booster stage, because I know that that's a booster. And which of these is going to hit first? Okay, so this one hit first. So that was the second simulation. So by not moving at 300 miles an hour, the rocket hit the ground faster. It's because, yeah, because you had 300 miles of velocity going this way. That makes it a difference in the trajectory. Okay, so the question that Low Budget Bob says, and everybody's answering him for him, what dictates the center of pressure of a rocket? And D. Hagen 6278 says, not sure if he answered it, but basically the geometry of everything in the airstream: nose, airframe, fins, tail cone, launch lug, rail buttons, surface finish to a lesser extent. So, yep, that is correct. So anything on the outside of the rocket is going to affect the center of pressure, except for the launch or the body tube. Because the equations, and you probably heard about these, the equations that govern the center pressure are called the Barrowman equations. And all components on the outside of the rocket will affect the location of the CP except for body tubes. Because body tubes don't create any lift force unless they're at an angle of attack. So technically they do, but it's so small that for all intents and purposes, they're ignored. So let me change this rocket to just a single stage. Let's look at it in the 2D view. And so the center pressure is right here. So we can change the location of that center of pressure by changing anything on the outside. So I can change the nose cone, I can change the transition, or I can change the fins. I have a tube right here. This is not going to affect it. And this tube right here is not going to affect it. And then anything on the inside of the rocket doesn't affect it. The stuff on the inside affects the center of gravity, not the center of pressure. So center of pressure is where the aerodynamic forces are balanced. And there's 4 forces acting on a rocket. 2 of them are aerodynamic. So the 4 forces are lift and drag. And those are the 2 aerodynamic forces. And the other 2 forces are thrust from the rocket motor and gravity from the earth. So those are the 4 forces. So this tells me where all the aerodynamic forces balance. So that's where our lift and drag balance. And the center of gravity is where the gravity force is balanced. So if you balance it on your finger, that's where gravity is said to be concentrated, because it will balance at that point. For a rocket to be stable, the center of gravity must be in front of the center of pressure. That's the definition. That's what's going to make the rocket fly straight. If this center of gravity gets behind the center of pressure, then we have an unstable rocket. So I can change the location of the center of pressure, as I said, by changing the fins, changing the transition, or changing the nose cone. The biggest effect is the fins. And this is why if you remove the fins from a rocket, it'll pretty much go unstable. So we can come to this fin set right here. Let me just change it to a single stage. And like I can change the location. Right now these fins are located from the base of the owning part. So if I make this number greater, what that means is it's going to move forward along the tube. And I can slide it greater, and you'll see that as I move my fins, the center of pressure is also moving. And if I get the fins in front of the center of gravity, now we have an unstable rocket. And if I keep moving them forward, you'll see that I can actually move them onto the transition. And if I keep moving them forward, at some point, this gets to the end, but I can actually come to this number right here and type in a number. Let's make it 9.5 inches. You can see that I moved it a little bit too far, so let's go 9.4. Okay, so now I moved them at the front of the nose cone. So if I look at it in 3D, you'll see that they're, let's see if I can get them to conform to the tube. Doesn't want to. But you can actually put fins on the transition, and you can put fins on the nose cone. You can put fins on the tube just by moving the location. It's just where you're measuring from. So that is what controls the center of pressure on a rocket. Very important that the center of pressure must be behind the center of gravity. The distance, not so important. The distance affects how much weathercocking the rocket's going to do, but I would rather have more weathercocking than having it where it's on that hairy edge of stability. And that means that the center of pressure and the center of gravity are so close together. I want some distance in between. And typically you want the distance to be at least one body tube diameter. And in this case, the body tube diameter is this one right here. Because we're using the maximum frontal area. AB Hobby says, I am building a rocket with a 38 motor tube. I would like to fly with a 29 millimeter motor adapter tube. How do I make the 29 millimeter adapter a subassembly or use it in, and how do I make the 29 millimeter motor adapter a subassembly and use it in flight simulations? Okay. Let's open up a rocket with a 38. So let's go to File, Open. The Zephyr is a 38. Save my changes? No. Okay, so here's a rocket, and it has a 38 millimeter motor in it. So here is the quick and dirty, fast way, and this is the way that I use. And why do I use this rather than making a subassembly? And the reason is, as we just discussed, the subassembly is not going to affect the center of gravity or the center of pressure because it's an internal part. It's only going to affect the center of gravity of where it balances. So if I know the weight of a motor mount adapter, so if I come to the Apogee website and if I go to shopping, building supplies, we want motor mount adapters. Where are my adapters? They're there. Here's ready to use adapters. So we have an Aeropack 29 to 38 motor mount adapter. If I click on this, and it'll tell me the weight of this item. So it's right here, 39.3 grams. So the quick and dirty way is just put a mass object back here that weighs 39.3 grams, and then just shove in a 29 millimeter motor. And that accounts for the weight of the adapter and the weight of the motor. and you can do it really quick. So, so here's where I'm going to put my mass object. So I'm going to click mass object. And again, it always tries to look in the database, so I'm going to cancel out of the database. So here's the mass. I'm going to say 39.3 grams. And then I need to select the location. So right now, the location is from the front of the owning part. So this tube right here is the owning part. So that's why it's right here. We just want to slide it back to where we think it's going to be inside the rocket. So here is the mass. And I'll just click OK. Let's call this motor mount adapter mass. And click OK. So there's the mass. And then to run a simulation, just come up here to run the simulation. And so now we're going to choose an engine. So right now you'll see that it's looking for 38s, but we want to put a 29 in. So come up here to the diameter filter and choose show only the engines that match the motor mount diameter, and matching would mean 38, or are smaller. So now we can choose smaller motors. So now we're going to, so they're going to sort by diameter. So just click on the column header and that sorts it from the smallest to biggest. And we're going to come down to the 29s. And then you want to select your 29 millimeter motor. Let's say we've got an H motor. So I'm going down to the H's. So an H135, 29 millimeter motor. 14-second delay. Click OK. Flight events, let's say max ejection delay, so that's going to be 14 seconds. That might be too long. We'll find out here in a second. This is a 38, so this time we do want to use a 96-inch launch rod, which should be 8 feet, 7.9999. We do want to launch it straight up, so it's 0 degrees. Fixed to the earth. Launch conditions, so now we want to go 227 feet above sea level. And our wind table, so we got an 8-mile-an-hour wind, hit the flight profile. So now we just ran the simulation with an H135, which is a 29 millimeter inside a 38 millimeter motor mount. And that was how quick we did it. So there's our rocket sitting on the pad. And when we launch it, it's going to be in the air for 74 seconds, so I think the parachute did come out in time. It's going to go over the top. There's where the parachute popped out, and then it's going to drift down to the ground. And it landed in the cemetery. Okay, so there's the trajectory of our rocket. So the launch point was right here. It went up, kind of waffled around a little bit. At 14 seconds, the parachute came out, and it came down right here. All right, so that is the quick and dirty, easy way to do it. And it's going to be just as accurate as building a subassembly. Do I want to build a subassembly really quick? We got one more question. Simulating an Estes Pro Series Majestic RockSim Pro shows the 29 millimeter Estes motor is recommended as not safe. I think it's too slow coming off the rod, even with this, even the 6-foot rail isn't long enough. Do I have? Let me do this Majestic question, and we're already after 3 o'clock, so it can't. Remind me next week to do subassemblies. And I'll build a subassembly. It takes a little longer. It's a little bit more complicated. That's why I like using the cheats of just using a mass object, because it doesn't affect the aerodynamics. It doesn't affect thrust. It doesn't affect the drag force or lift force. The only thing that it affects is gravity. So we accounted for that by adding a mass object, which is the weight of the item. And then we just ran a simulation by picking a skinnier diameter motor. Okay, so we're doing an Estes Majestic. Just Majestic rocket. And I'm going to do a RockSim file. See if one pops up. RockSim design file. Okay, so here's what it looks like. You can download it here, so I'm going to download it. It'll allow that. Okay, so it put it in my downloads folder. So here is that Majestic. So I'm going to take that and just drag it onto RockSim, and it says, do I want to save that other design? And I'm going to say no. So there's the Majestic. Here's it in 3D. Somebody went through some nice work to make this as nice as possible. Although the fin looks a little weird. Oh, they selected airfoil. Okay. Okay, so, and he says, I got the rocket from Rocket Reviews, and it was seen as modeled correctly, but didn't check the weight of every component or anything. I don't have the rocket built. Okay, so if I look at it in 2D, I can see what the mass is, 201 grams. I don't know, that doesn't seem like out of the ordinary. So, you know, you'll build it and you weigh it, and then you'll be accurate. So let's do, okay, so the 29 millimeter Estes motors. So let's go to find the motor. So we're going to go choose an engine. And this time I want to select only motors that match the motor mount diameter. So now it's selected only the 29s. And then I want to scroll down to the Estes section. So we have an E16 or an F15. So here's the bigger motor. I'll select that. Ejection delay. I'll choose the longest one. Engine overhang, I'm going to say it's a 1/2 of an inch hanging out the back. Click OK. You'll see that it loaded the motor back here. Flight events, starting state. Let's see, he said he had a 60-inch launch rod, 72-inch. He had 6 foot long. Launching straight up. Launch conditions, that same launch site, wind table, still 8 miles an hour. Let's do a launch. Okay, so it shows that the rocket crashed. So that typically means that the 8-second was too long. It did reach 1,559 feet. What I'm looking for is velocity at launch guide departure, which should be this column right here. And it shows it at 33 miles per hour. And I would say that's okay. So my opinion is that this rocket would be safe to fly on the F-15. It does have enough power, although it's saying 8 seconds is too long. So let's look at the flight profile. And see when that parachute lands. Okay, so let's zoom out. So there's the rocket on the launch pad right there where my cursor is. And we launch it. It's only in the air for 22 seconds. So it's going up. It's still burning. It burned out. It's going higher than my screen. It's coming down. So it's starting to pick up speed. That parachute should have came out long before this. This should have been an 8-second delay, which tells me I got something set up wrong. So I'm going to go back here to the setup. I think under flight events we have the parachute as no event. So we want to say max ejection delay. And let's launch it again. It's still reaching 1,559 feet. But this time it's in the air for 67 seconds. You can see that right here. This is our time. And let's launch it. It's taken off. going up. Burned out, so the clock is started on 8 seconds. So somewhere around 10 or 11 seconds, it should pop out parachute. There it is. And the parachute's coming out. Parachute landed. Let me zoom out a little bit and see what this trajectory looks like. So the other thing that I'm going to look at is, did it weathercock too much? Weathercocking means we got a wind coming out of the west. So north is to the top of the screen. So often the distance is north. So the west would be here on the left side. So we have wind coming out of the west blowing this way. And so the rocket turned or weathercocked into the wind. So did it weathercock too much? And the answer is it was okay. And the reason I know is because this apogee point, it's colored green. If it was red, that means it's weathercocking too much. I can show the weathercocking cone right here, and I can explain what this means. So if the apogee point is within this cone right here, that's assumed to be a safe weathercocking. It means it's going more up than sideways. And so when it stays within the cone, it makes that dot green. If it's on the outside of the cone, it would be red. So as long as I see a green dot right here, I'm okay with it. So I'm okay with launching this rocket on the F-15-8. Now the delay, velocity, I'm looking for velocity at deployment right here, this column. Velocity at deployment, it was 30.96 miles per hour. I think that's okay. I like to see that number below 50. And so it's below 50 miles an hour. So I would say my parachute is probably going to survive. If it's a nylon parachute. If it's a plastic parachute, you might want to go with a lower value. But that's okay. So I'm okay with that flight. And that's basically, you know, how I determine is it working. So now his saying it wasn't safe. So he's saying I think I used a 4-foot rod, but I tried a 6-foot to check if it was marginal. So this number, velocity at launch guide departure, depends on how long the launch rod is. So if we change the launch rod length, so right now we have a 6-foot rod. If we make it a 36, which is a 3-foot rod, which is like your standard Estes maxi rod, and we launch that. Okay, so now we're at 20 miles an hour. So that would be definitely no. It's not coming off the rod fast enough. So what does that look like if we go here to that flight profile again? And we look at a trajectory view and swing the compass to the north. And now we launch it. Okay, you can see that the trajectory looks a little different because it's not weathercocking as much because it was coming off slower. The rocket kind of got pushed sideways, but it didn't weathercock as much. So I'd actually be okay with that one too, although I do want to see a higher liftoff speed because it's such a low liftoff speed, you're never sure. So I want to see that number about 30 miles an hour. So I'd like to see it higher than 20. So if I go to a 48-inch launch rod, starting state, 48 inches. So now I'm at 4 feet. And hit launch. So now I'm at 25 miles an hour. So I'm still a little slow. better, but still a little bit slow. It's kind of hinky on that one. I would say don't launch it with any wind on that in that situation, because you never know what the wind is going to do. A wind is a force. It affects lift and drag. Very cool question, though. It was fun. Yeah, but now we're out of time, so remind me next week to run the subassembly. And then I'll show you how to make that motor mount adapter. That's a good use for a subassembly, but again, it's so much faster just to use a mass object. I will be back next week. It's 2 weeks from now that I have to go to Texas. So we'll be back next week, same time, 2 p.m. I'll send out a schedule on YouTube, so you'll get an alert in your email if you're a subscriber to this channel. So make sure you hit that subscribe button so that 5 minutes before 2 o'clock next week, you'll get an email say, hey, we're going live. And I do appreciate you subscribing. And give us a thumbs up if you learned anything new. And a thumbs down if you're a Launch Visualizer customer. Don't do that. If you're a Launch Visualizer customer, come to us. We'll get you hooked up in RockSim Pro. And in RockSim Pro, we have this deal for everybody, no matter who you are. If you spend $30 with us, we're going to give you a free month of RockSim Pro. So, you know, you'll get your rocket motors, or you'll get a kit, and you'll get to use RockSim Pro for 30 days. And then you can do it again next month. Same deal. So you can just keep doing that over and over and over again whenever you need to use RockSim Pro. All right, so thank you again for being here. I'll switch over to the ending. I'm being covered up by the subscribe button. Yeah, I'll give you a countdown and we'll get out of here. So if you're launching tomorrow in the cold weather, good luck, but I wish you well. So in 5, 4, 3, 2, 1, go out and launch something.